January 17, 1944. The Pacific sun beat down relentlessly on a narrow strip of coral and sand. Waves crashed against the jagged coastline, sending salty spray into the air. Smoke from distant artillery mingled with the tropical humidity, thick and suffocating. Amid the chaos, a group of U.S. Navy Seabees moved like clockwork, bulldozers carving through dense jungle, heavy machinery groaning under the strain of freshly landed supplies. The smell of diesel, sweat, and wet earth hung in the air. Japanese soldiers crouched in hidden bunkers along the ridge, binoculars trained on the sudden flurry of activity. They could scarcely believe the speed of construction, an entire runway taking shape in days, not weeks. Trenches were dug, coral crushed and leveled, and timber frameworks erected with almost surgical precision. Every movement of the Seabees carried urgency. The island would soon become a launching point for U.S. aircraft that could dominate the surrounding seas. From the cliffs above, the enemy watched silently. Disbelief etched on their faces, knowing that whatever advantage they had counted on was slipping away, one plank and one shovel at a time. The race against time had begun, and the outcome would reshape the Pacific War. By early 1943, the war in the Pacific had reached a brutal stalemate. Japanese forces, after their initial sweeping advances in 1941 and 1942, had fortified a string of islands across the Central and South Pacific. Each island, from Tarawa to Guadalcanal, had been transformed into a network of bunkers, artillery emplacements, and supply depots. For the Allied forces, the challenge was immense. Every gain required crossing thousands of miles of open ocean, landing on hostile shores, and sustaining a fight far from established bases. The United States, recognizing the impossibility of a direct invasion of Japan at this stage, adopted a strategy that would come to be known as island hopping. The plan was deceptively simple: bypass the strongest Japanese positions, seize strategically located islands, and use them as forward bases to project air power further into enemy territory. Success depended not just on combat troops, but on the engineers who could transform inhospitable, coral-laden islands into functional airfields capable of handling fighter and bomber aircraft. Japanese defensive doctrine relied heavily on natural terrain. Dense jungles, rocky shores, and lagoons were augmented by carefully concealed bunkers and coastal artillery. The defenders were often fanatically determined, trained to inflict maximum casualties on any invading force. Each island presented unique challenges. Coral reefs prevented easy landings, swamps and mangroves slowed troop movement, and tropical storms could wash away hastily built infrastructure. For U.S. forces, the solution had to be both rapid and adaptable. Enter the Navy construction battalions known as the Seabees. Formed in 1942, the Seabees were a revolutionary force. Military engineers trained not only in construction but also in combat. They carried the dual responsibility of building airstrips, roads, and bases under fire, while remaining ready to fight alongside Marines and infantrymen. Their motto, "We build, we fight," reflected a mindset that would define the success of the Pacific Campaign. Early operations revealed the scale of the task. On Guadalcanal, engineers worked around the clock to repair captured Japanese airfields and expand them to accommodate U.S. aircraft. At Tarawa, the Seabees had to flatten coral ridges under shellfire and bombardment. Each mission tested their ingenuity. When bulldozers bogged down in swamps, they improvised planks and fascines. When coral was too jagged, it was crushed and spread by hand and machinery. Logistics were equally complex. Equipment and supplies had to be delivered across hundreds of miles of ocean, often under threat of submarine or air attack. Fuel, steel, cement, and timber arrived in precarious quantities, each shipment meticulously prioritized. The pressure on these engineers was relentless. Commanders understood that every day gained in construction meant aircraft could take off to support advancing troops, interdict enemy shipping, and provide air cover for future landings. Japanese forces, meanwhile, observed these developments with growing alarm. They recognized that the speed at which U.S. engineers could transform an island into a functioning base undermined their own defensive calculations. Islands once thought secure were suddenly within reach of U.S. bombers. By the time of the Gilbert and Marshall Islands campaigns in late 1943, rapid airstrip construction had become a decisive tool of war. The Seabees' ability to build in days what once took months allowed American forces to maintain momentum, striking at lightly defended islands while bypassing others. Each successful landing and construction project brought the Allies closer to Japan's inner defensive perimeter. Yet every victory carried risk. Engineers worked under the constant threat of enemy artillery, snipers, and aerial bombing. Tropical disease, heat exhaustion, and supply shortages added to the hazards. In this crucible, the combination of military precision, technical skill, and sheer human endurance created a force unlike any other in the history of warfare. The speed of U.S. construction astonished both allies and enemies alike. From the cliffs where Japanese lookouts crouched in disbelief, to the jungles where Marines advanced behind freshly paved airstrips, a pattern emerged. Wherever the Seabees went, the war could follow, swift, calculated, and unstoppable. It was against this backdrop, an ocean of fortified islands, a desperate enemy, and a relentless Allied strategy, that the true significance of rapid airstrip construction would be revealed. The next section will explore the continuation of these challenges and the logistics that made such feats possible, setting the stage for the human and technological angles that defined the campaign. The islands of the Pacific were not merely distant dots on a map. They were hostile worlds unto themselves. Dense jungles clung to jagged volcanic ridges. Mangrove swamps and coral reefs blocked easy landings. Torrential rain turned sandy beaches into quagmires. For the U.S. forces, conquering these islands meant overcoming nature itself before even engaging the enemy. The logistics alone were staggering. Every bulldozer, crane, and truck had to be shipped thousands of miles from supply bases in Australia, Hawaii, or the U.S. West Coast. Fuel, cement, steel, and food had to arrive on time. A single delay could stall construction, leaving troops exposed to Japanese counterattacks. Once ashore, Seabees faced relentless pressure. Enemy fire was constant, from hidden artillery to sniper positions. Japanese forces, well-trained in observation and defense, sought to disrupt construction at every opportunity. On some islands, booby traps and mines littered likely building sites. On others, storms threatened to wash away freshly leveled coral or flatten wooden structures before aircraft could land. Despite these obstacles, the Seabees adapted rapidly. Bulldozers were modified to crush coral, trucks reinforced to carry heavy equipment over rough terrain, and improvised drainage systems channeled torrential rainwater away from runways. Their work combined military discipline with engineering ingenuity, a blend of precision and improvisation rarely seen in combat. The speed of construction was not simply about building airstrips. It was about sustaining momentum. Each captured island needed to be operational immediately. Aircraft had to take off the moment the first planes landed, providing reconnaissance, close air support, and interdiction against Japanese supply lines. This urgency forced engineers to rethink traditional methods. Runways were laid using crushed coral compacted by rollers, sometimes hardened with bitumen or steel mats. Entire facilities, from fuel depots to control towers, were constructed in parallel, with teams working around the clock under the threat of enemy attack. Japanese forces were quick to notice. From observation posts hidden in cliffs or deep in the jungle, enemy soldiers recorded the astonishing pace of U.S. construction. They saw men moving as if possessed, machinery roaring through forests and runways rising out of untamed landscapes. Reports from the time recount Japanese disbelief. Islands thought secure for months were transformed in days, giving American forces unprecedented flexibility and reach. By late 1943, this combination of speed, adaptability, and raw human endurance had begun to shift the balance of power in the Pacific. The Seabees' work enabled operations on Tarawa, Makin, and Kwajalein, successes that would have been impossible with traditional military engineering approaches. They proved that warfare in the Pacific was not just about firepower and troop numbers. It was about logistics, ingenuity, and the ability to tame hostile environments faster than the enemy could respond. As U.S. forces moved from island to island, each airstrip became a forward base, a springboard for the next offensive. The Japanese, meanwhile, were forced into a reactive stance, often retreating or abandoning positions they had invested heavily in defending. In the coming sections, we will explore the human, tactical, and technological angles of this remarkable phenomenon. The men who built these airstrips, the machines they mastered, and the decisions that turned small islands into crucial footholds in a global conflict. The men of the Seabees were more than engineers. They were soldiers first, builders second. Each landing on a Pacific island was a leap into uncertainty, a crucible of mud, heat, and enemy fire. Imagine stepping off a landing craft onto a narrow beach, coral jagged beneath your boots, machine gun fire cracking from unseen bunkers. Sweat poured from every pore, yet the Seabees moved with precision. Their workdays stretched from dawn to midnight, punctuated by bursts of enemy artillery and strafing aircraft. Camaraderie became a lifeline. Teams worked in small units, each member knowing the role of the others instinctively. Some cleared jungle with machetes and explosives. Others leveled coral with bulldozers, while medics and cooks ensured the men could continue under extreme conditions. Letters home spoke of exhaustion, yet also of pride. The sense that their labor, often under fire, was decisive in a war thousands of miles from home. The psychological toll was immense. Working under constant threat, often with wounded soldiers nearby, demanded nerves of steel. Sleep was scarce. Meals were improvised. Injuries were treated in field tents. Yet the Seabees endured. Each completed runway was not merely a technical achievement. It was a statement of human resolve, a defiance of both nature and enemy fire. The men learned to thrive under chaos, transforming fear into efficiency and precision. Airstrips were more than patches of leveled ground. They were the linchpins of the Pacific campaign. A single operational runway could project air power hundreds of miles, allowing fighter cover for advancing Marines, bombing raids on enemy positions, and reconnaissance flights that mapped Japanese fortifications. Rapid construction meant that the tempo of the war could be maintained. U.S. forces did not pause to consolidate. They moved relentlessly from one island to the next. Commanders understood that the speed at which a runway became operational directly affected tactical decisions. In battles such as Tarawa and Kwajalein, delays in construction could have cost lives and momentum. Conversely, a runway ready within days allowed air support to dominate, suppressing Japanese defenses before they could regroup. In this way, engineering became a weapon as decisive as artillery or aircraft. From the Japanese perspective, the phenomenon was bewildering. Defensive plans assumed that any captured island would remain isolated for weeks or months. When aircraft began taking off almost immediately, the defensive calculus collapsed. Islands thought secure were suddenly vulnerable, forcing hurried redeployments and leaving troops in exposed positions. The strategic advantage conferred by rapid airstrip construction reshaped not only individual battles but the broader island-hopping campaign. The methods employed by the Seabees were as innovative as they were practical. Bulldozers modified with steel cleats crushed coral and leveled uneven terrain. Pneumatic drills tore through volcanic rock. Steel mats, portable and durable, allowed aircraft to land on previously unmanageable beaches. Engineers developed drainage systems that could withstand torrential tropical rain, and concrete was poured in modular sections to accelerate runway readiness. Every machine and tool was adapted to the environment. In some cases, vehicles were waterproofed to cross flooded areas. In others, local coral and timber were repurposed, reducing reliance on long supply chains. The Seabees' ingenuity turned raw material into infrastructure at a rate that astonished both allies and enemies. This technology was not just mechanical, it was procedural. Construction teams worked in overlapping shifts, each step choreographed to maximize speed and efficiency. From clearing the jungle to compacting coral, each process was optimized, refined, and repeated across dozens of islands. By the end of 1943, this combination of adaptive technology and procedural innovation had become a signature advantage of the U.S. Navy in the Pacific. The speed and effectiveness of airstrip construction in the Pacific owed as much to leadership as to manpower or technology. Commanders at every level understood that time was the ultimate currency in island warfare. From Admiral Chester W. Nimitz, overseeing the vast Pacific theater, to Seabee officers directing work crews on individual beaches, decisions were made under pressure, often with incomplete information. Orders were clear: seize the island, establish a secure perimeter, and build operational airfields immediately. Flexibility was paramount. When unexpected obstacles appeared, a coral ridge too jagged to level, a swamp blocking a runway, or sudden enemy artillery fire, leaders had to make instant choices, improvising solutions while keeping the overall objective in mind. This combination of strategic foresight and tactical adaptability allowed U.S. forces to maintain momentum even in the face of setbacks. On the ground, Seabee officers coordinated closely with Marine units. Bulldozers and trucks were deployed in precise sequences to avoid bottlenecks. Demolition teams cleared obstacles under fire, while engineers surveyed terrain for the fastest possible path to a functional airstrip. Leadership extended beyond military hierarchy. Small unit initiative was encouraged, empowering teams to solve problems independently while staying aligned with overarching objectives. The result was a decentralized efficiency that rivaled traditional military operations in speed and effectiveness. Japanese soldiers and commanders were both impressed and alarmed by the rapid construction. Reports from observers often noted disbelief. Islands thought secure for months were transformed into functional air bases in days. From hidden bunkers they watched bulldozers flatten jungle, coral crushed and compacted, and temporary control towers erected seemingly overnight. The Japanese response varied. On some islands they attempted counterattacks or sabotage, targeting construction crews and supply lines. Snipers, mortars, and aerial strikes were deployed to slow progress. Yet the adaptability of the Seabees and Marines often neutralized these efforts. When a runway section was damaged, repairs were completed within hours. When supplies were delayed, local materials were repurposed to maintain construction. Psychologically, the speed of U.S. engineering had a demoralizing effect. Troops who expected to hold an island for weeks or months saw the enemy establishing operational bases almost immediately. This undermined confidence and forced defensive reallocations, leaving Japanese forces vulnerable elsewhere. The combination of disbelief and rapid U.S. action created a compounding effect. Each successful landing and airstrip construction strengthened Allied momentum while weakening Japanese resolve. Rapid construction, while strategically vital, also carried ethical and human implications. Seabees often worked alongside infantry in contested areas, exposing themselves to artillery, mines, and ambush. Their labor accelerated combat operations, which meant enemy casualties increased as aircraft gained immediate reach. At the same time, the islands themselves suffered catastrophic environmental alteration. Jungles were leveled, coral reefs crushed, and local ecosystems destroyed. Letters and reports from the time reflect the tension between duty and conscience. Many Seabees recognized the deadly consequences of their work. Their airstrips allowed bombers to strike enemy positions, often resulting in high casualties. Yet these men understood that speed was essential to save lives in the long term. A delayed airfield could prolong battles, increasing fatalities among Marines and sailors. This ethical complexity underpinned every operation. A silent awareness woven into the fabric of every shift, every planked runway, every ton of crushed coral. November 20th, 1943, Tarawa Atoll. The sun had barely risen over the horizon when the first waves of U.S. Marines hit the beaches. Coral reefs tore at landing craft, forcing troops into waist-deep water as Japanese machine guns opened fire from well-fortified bunkers. The assault was brutal, a clash of human endurance against meticulously prepared defenses. Yet while the infantry fought tooth and nail to secure the island, another battle was already underway, the battle to build a functional airstrip under fire. Seabees landed shortly after the first waves, their equipment scattered across the tide-swept beaches. Bulldozers, cranes, and trucks had to be unloaded quickly, often under enemy fire. Engineers moved with precision, cutting paths through coral and debris, leveling landing zones for the first aircraft. Mortars and sniper fire punctuated their work, but the Seabees pressed on, knowing that every hour gained meant aircraft could provide close support to Marines still pinned down in the sand. By midday, rudimentary strips of crushed coral had been laid. The first liaison planes began to taxi cautiously, carrying supplies and medics. Each successful landing shifted the dynamic on the battlefield. Japanese defenders, expecting weeks of delay, found their positions increasingly vulnerable as airstrikes targeted bunkers, artillery, and troop concentrations. The speed at which the Seabees transformed the island confounded enemy calculations and gave the U.S. forces a tangible advantage that went beyond mere numbers. Tarawa was only the beginning. In February 1944, the seizure of Kwajalein and the Marshall Islands presented a similar challenge. Engineers had to contend with soft coral, swamps, and heavy artillery fire from entrenched Japanese positions. Seabees worked around the clock, employing steel mats, drainage systems, and innovative construction techniques to create runways capable of handling heavy bombers. By the fifth day, The first fighter aircraft took off, providing critical air cover for Marines advancing inland. Japanese resistance faltered as their positions came under constant aerial attack, a direct consequence of rapid airstrip construction. On Saipan, June 15, 1944, the Japanese forces dug into caves and fortified ridges, expected to hold out against a protracted invasion. Yet Seabees, landing within hours of Marines, began flattening jungle and coral, with a determination that seemed almost mechanical. By the end of the first week, an airstrip was operational, allowing U.S. planes to provide continuous support. For the defenders, the psychological impact was devastating. No island, no matter how fortified, could remain isolated from American firepower. The decisive element in each of these campaigns was not merely the presence of engineers, but the orchestration of men, machines, and materials in perfect sequence. Bulldozers cleared obstacles while survey teams laid out runways. Trucks transported crushed coral as compactors pressed it into level surfaces. Temporary control towers and fuel depots went up simultaneously, ensuring that the first aircraft could land without delay. Every hour of work was a race against enemy counterattacks, tropical storms, and the natural challenges of remote islands. By July 1944, the cumulative effect of these operations became clear. Islands once considered secure strongholds were no longer insurmountable. Japanese defensive plans, which relied on isolation and attrition, collapsed in the face of near-instantaneous American airfield construction. Commanders on the front lines noted the unprecedented tempo. Air support followed troops almost immediately, naval bombardments were complemented by daily sorties, and supply lines moved faster than ever before. The combination of strategy, human endurance, and engineering mastery reached its apex at Saipan. Within days, the island shifted from a contested battleground to a forward base projecting air power across the Marianas. Japanese soldiers, many in despair, witnessed the full force of American ingenuity. They could see planes taking off from ground that had been jungle mere days before. Each aircraft carried not only bombs and fuel but a message. The enemy's previous advantage was gone. The speed and precision of these operations turned isolated engagements into decisive victories. The ability to seize an island and immediately transform it into a launchpad for further offensives gave the United States a strategic flexibility Japan could not match. It was a turning point in the Pacific War, where engineering skill, logistical planning, and combat courage converged to redefine the possibilities of modern warfare. The next section will continue this climax, detailing the operational culmination on Saipan and other islands, showing how these rapid airstrip constructions directly determined the outcome of battles and the trajectory of the Pacific Campaign. The battle for Saipan was emblematic of the culmination of U.S. engineering and combat synergy in the Pacific. By June 16, 1944, Marines had secured key beachheads, but dense jungle and fortified ridges blocked further inland advances. Seabees landed simultaneously with follow-on forces, their mission clear: transform the captured terrain into operational airstrips before the Japanese could regroup. Bulldozers roared through undergrowth, coral was crushed and compacted, and temporary matting created runways capable of handling fighter aircraft. Every hour counted. Japanese artillery shelled the beaches, aiming to disrupt construction, but the Seabees pressed on. Survey teams worked under fire, determining the fastest route to a usable runway. Engineers lifted timber and steel into place, improvising when traditional materials were scarce. Small unit initiative was critical. When a crater from enemy shelling blocked a key section of the airfield, a handful of men repaired it within hours, ensuring planes could land without delay. By June 21st, just 6 days after the initial landings, the first fighter aircraft took off from the newly completed airstrip. The impact was immediate. Close air support began targeting Japanese positions on Mount Tapachau and along the northern ridges, suppressing counterattacks and allowing Marines to advance with reduced casualties. Reconnaissance flights identified enemy movements across the island, while bombers disrupted reinforcements approaching by sea. The rapid construction of airfields had transformed Saipan from a contested battleground into a forward operating base projecting American power across the Marianas. The operational consequences extended beyond the island itself. From Saipan, U.S. aircraft could reach the Bonin Islands, the Volcano Islands, and even threatened the Japanese home islands directly. The combination of tactical and logistical speed gave the Americans a strategic reach Japan could not counter. The Japanese high command realized that even heavily fortified islands could no longer delay American advances. The war had entered a new phase. Isolation was no longer protection, and rapid engineering had become a decisive instrument of warfare. A similar pattern played out across the Central Pacific. On Tinian, engineers completed an airfield in record time following the initial landings in July 1944. Japanese forces, demoralized and under constant aerial bombardment, could not prevent construction. By the end of the month, Tinian's airstrips supported the largest bomber raids in the Pacific to date, including the B-29 operations that would later strike the Japanese mainland. Kwajalein and Eniwetok had been transformed into hubs of U.S. air power within days of capture, amplifying the operational tempo and constraining Japanese maneuver options. The decisive factor in each instance was the seamless integration of manpower, leadership, and technology. Seabees worked in shifts around the clock, their progress tracked and coordinated with infantry, naval, and air units. Bulldozers, graders, rollers, and trucks were deployed with military precision. Temporary facilities for fuel, maintenance, and command were constructed in tandem, ensuring the airfield was immediately operational. This orchestration turned raw, hostile terrain into a platform capable of projecting lethal force, a feat that both astounded and demoralized Japanese defenders. For the Japanese soldiers who remained, the experience was harrowing. Reports describe bunker commanders observing American aircraft taking off from ground that had been jungle or reef only days before. The speed and audacity of these operations defied expectations. Defensive plans, often predicated on the assumption that islands could be isolated for extended periods, were rendered obsolete. The psychological impact was profound. Hope for protracted resistance diminished as enemy firepower became increasingly irrelevant against the operational reach of U.S. air power. By mid-1944, the pattern was clear. Islands were captured and converted into air bases with a speed and efficiency unprecedented in military history. Each successful operation reinforced the strategy of island hopping, enabling subsequent assaults on the Marianas and beyond. Engineering, previously a supporting element of warfare, had become a central determinant of victory. The rapid airfield constructions at Tarawa, Kwajalein, Saipan, and Tinian marked a turning point in the Pacific theater, where American ingenuity, discipline, and courage combined to overcome geography, enemy fortification, and the clock itself. The momentum generated by these feats set the stage for the next phase, the aftermath. The consequences were felt not only on the battlefield but also in Japanese strategy, morale, and the larger trajectory of the war. Islands once thought secure had fallen quickly. Air power now dominated previously uncontested skies, and the Allies had established a new operational tempo that Japan could not match. The next section will examine this aftermath, detailing losses, gains, and the strategic and psychological consequences of these extraordinary operations. The capture and rapid transformation of Pacific islands into operational airfields had consequences that reverberated across the theater of war. At Tarawa, Kwajalein, Saipan, and Tinian, the U.S. forces not only secured strategic positions, but also demonstrated the full impact of engineering speed on modern combat. Casualty figures on both sides reflected the intensity of these operations. Tarawa alone saw over 1,000 U.S. Marines killed and nearly 2,000 wounded in just 3 days, while Japanese defenders suffered almost total annihilation, with over 4,000 troops lost. The human cost was high, yet the airstrips built under fire proved decisive in reducing the duration of combat, allowing reinforcements, supplies, and medevac flights to reach the front lines without delay. Beyond immediate losses, the strategic significance of these airfields was profound. Once operational, they enabled continuous air cover for advancing forces, extending U.S. reach into Japanese-controlled territories. Bombers and fighters launched from these islands disrupted supply lines, destroyed artillery positions, and provided reconnaissance that informed tactical decisions. The rapid availability of air power meant that subsequent assaults could be launched with a level of coordination and precision previously unimaginable in the Pacific theater. Japanese forces were forced into increasingly desperate defensive measures. Islands once considered formidable strongholds were neutralized with remarkable speed, undermining morale and creating a sense of inevitability among troops and commanders alike. Reports from Japanese officers indicate frustration and disbelief at the pace of American engineering. They faced a dual challenge, fighting an advancing enemy while simultaneously watching them turn the very ground beneath their feet into operational air bases. This psychological pressure, combined with heavy casualties and isolation, contributed to a decline in resistance on subsequent islands. Logistical and operational efficiency on the American side reinforced these outcomes. Seabees continued to refine their methods. Crushed coral runways, portable steel mats, and modular fuel and maintenance depots became standardized solutions. Each successful construction project informed the next, reducing delays and minimizing exposure to enemy fire. By mid-1944, the United States had effectively created a network of forward bases across the Central Pacific, each capable of supporting sustained offensive operations. The broader implications were evident in the speed and success of the island-hopping strategy. Capturing and rapidly converting islands allowed the Allies to bypass heavily fortified positions, focusing resources on strategically valuable targets. The combination of engineering prowess and combat capability created a compounding effect. Every new airstrip increased operational reach, reduced enemy options, and shortened the duration of engagements. In this way, rapid construction became a force multiplier, amplifying the impact of manpower, artillery, and naval support. Beyond the battlefield, the aftermath of these operations highlighted the central role of engineering in modern warfare. The Seabees' achievements challenged traditional notions of military hierarchy and battlefield priorities. Construction under fire was no longer a secondary concern. It was decisive. The ability to transform terrain in days rather than weeks reshaped strategic planning, forcing both allies and enemies to account for a new operational tempo that emphasized speed, adaptability, and coordination. By mid-1944, the cumulative effect of rapid airstrip construction had begun to reshape the Pacific War. Japanese defensive strategy, which had long relied on isolated islands serving as strong points, was collapsing. Islands that were expected to hold out for weeks or months fell within days, often before reinforcements could arrive. The psychological impact on Japanese soldiers and commanders was profound. Reports from surviving officers described a sense of helplessness as American forces landed, secured beachheads, and immediately projected air power from newly constructed airfields. The perception of invincibility that had accompanied Japan's early campaigns was eroding under the combined pressure of speed, firepower, and engineering. The strategic consequences were equally significant. From Saipan and Tinian, U.S. bombers could reach the Japanese home islands for the first time, signaling the beginning of a new phase in the war. Air superiority allowed for interdiction of supply lines, disruption of communications, and targeted strikes on strategic positions, diminishing the ability of Japanese forces to mount coordinated counterattacks. Each new airstrip reinforced the operational tempo, shortening battles, reducing prolonged exposure for frontline troops, and enabling the island-hopping strategy to maintain momentum. On the American side, the success of the Seabees and their rapid construction methods bolstered morale and validated the integration of engineering units into combat operations. Commanders increasingly relied on the promise that, within days of securing an island, it could support aircraft, logistics, and reinforcements. This confidence allowed planners to take calculated risks, accelerating the pace of the campaign and keeping Japanese forces perpetually on the defensive. The human cost, however, remained stark. Despite their skill and efficiency, Seabees and Marines alike endured grueling conditions: tropical heat, disease, constant enemy fire. Civilian populations on some islands suffered collateral damage as airstrips and bases were built, and local ecosystems were permanently altered. The speed of construction, while strategically invaluable, came with a toll that was physical, environmental, and ethical. Long-term, these operations demonstrated the transformative potential of engineering in modern warfare. Traditional combat units could no longer operate independently of infrastructure. Control of terrain required not only manpower but the ability to adapt it for immediate operational use. The Pacific Campaign became a testament to coordination between combat and construction, logistics and firepower, human ingenuity and discipline. By the conclusion of 1944, The U.S. had established a network of airstrips across the central and western Pacific that would prove critical for operations in the Philippines, Iwo Jima, and Okinawa. Japanese defenses had been progressively neutralized, not solely by force of arms, but by the ability to transform captured terrain into forward operating bases faster than the enemy could respond. The combination of speed, precision, and innovation ensured that the Allied momentum remained unbroken. The aftermath of these campaigns left an enduring legacy. Engineering became central to military doctrine. Rapid construction under fire was recognized as a decisive factor in operational success, and the psychological dominance gained through such capabilities reshaped how war was conducted in the Pacific. The stage was set for reflection, for a deeper understanding of what these extraordinary feats of human ingenuity and courage meant for history, warfare, and humanity itself. The next section will provide that calm, philosophical closure, reflecting on the significance of rapid airstrip construction and its lasting impact on the war. The sight of a newly completed airstrip rising from dense jungle or coral-strewn beaches was more than a technical achievement. It was a testament to human resilience, ingenuity, and determination. In the Pacific theater, where geography and climate seemed as much an enemy as fortified bunkers or artillery, U.S. engineers proved that speed and adaptability could redefine the possibilities of warfare. Each runway was a bridge between survival and victory, a literal and symbolic foundation for operations that would carry Allied forces ever closer to Japan. These airstrips changed the tempo of combat. Battles no longer lingered for weeks because aircraft could dominate skies almost immediately. Islands that had once seemed impregnable fell quickly, not solely through force of arms but through the orchestration of men, machines, and planning. The Seabees embodied this principle. Soldiers who built under fire, improvising solutions, adapting to the harshest conditions, and maintaining focus under unimaginable pressure. Their work demonstrated that engineering could be as decisive as artillery, infantry, or aircraft. Beyond military calculations, the story of these rapid constructions reflects broader truths about innovation and human will. When faced with obstacles, natural, logistical, or enemy, ingenuity, discipline, and cooperation can overcome them. The Japanese soldiers who watched in disbelief were witnessing not just bulldozers and coral, but the relentless application of knowledge and skill under pressure. These operations remind us that in war, the edge often comes from unexpected sources. The quiet resolve of men transforming the terrain beneath their feet. The legacy of these feats endures. Rapid airfield construction in the Pacific set a standard for military engineering, influencing